So now we're going to do the last couple of questions, or the last topic, which is Euclidean geometry. So we're going to do question 8, 9, and 10. So the first question says, in the diagram, chord KL, alright, then they tell us the chord LP and KP are drawn on the circle, as you can see, with the center O. Then they say SLR is a tangent to the circle at L, right? Then they say prove the theorem which state that the angle between the tangent SLK and chord KL is equal to the angle alternate segment. Then they say prove that SLK, which is this angle, right, is equals to angle P, right? So the first thing that we need to do is we need to construct a diameter, meaning we're going to connect L to O, then extend from O to create a line which is going to be T, then connect that T to K. So let's do that. Then what we're going to do is we're going to find a way to link angle SLK, right, what we require to prove, and angle P together. So the first thing that we see the fact that, and I'm going to do it in green, right? So what we see the fact that here it's a 90 degrees, right? Here touching the one that we extended is going to be 90 degrees, and the reason is going to be what? Tangent perpendicular to radius. So I'm gonna split this angle into two, as you can see the fact that it's into two. So I'm gonna write it in terms of its two angles, right? So the first one is going to be what? It's going to be SLK, right? So we're gonna say in green SLK, right, plus what? Plus the inner angle, which is what? Which is KLT, right? That is going to be equals to 90 degrees. And the reason for that is going to be what? As I said, it's going to be tangent perpendicular to radius. Then again, another thing that we're going to see is we're going to see the fact that this one is equals to 90 degrees, and the reason is what? Angle in a semicircle. So we know the fact that TKL, right? So TKL is equals to 90 degrees, and your reason is going to be what? Is angle in a semicircle, right? So after that, what do we see, right? We see the fact that, I'm going to do it in pink, we see the fact that angle T, this one, is equals to angle P, right? So we see the fact that angle T is equals to angle P, and your reason for that is going to be what? It's going to be angles in the same segment. So it's going to be angles in the same segment. All right, so now what do we need to do? We need to find a way of linking these two together to actually prove it, right? So what can I take? I can take this one that I'm going to highlight as a triangle. So I'm going to say in triangle KTL, right? What do I know? I know the fact that the sum of all angles is equals to 90 degrees. So I'm going to say angle LKP, angle LKT, right, plus KLT, or let me just call it, not to confuse, let me just call it angle T, which is this one I'm talking about, angle T, right, plus what? Plus this angle, which is KLT, right, is going to be equals to 180 degrees, and your reason for that is going to be what? Sum of angles in a triangle. Then after that is done, we know the fact that LKT is equals to 90 degrees. We already wrote that down, so we know the fact that this is going to be 90 degrees plus this is just going to be angle T plus KLT is equals to 180 degrees. Therefore, angle T plus KLT is equals to what? To 90 degrees, right? But what do we see? We see we can link this two. I'm gonna just highlight it in pink. We see the fact that here in the first one, this one, right, and looking at this one, we can basically link this one, right? We have KLT here and KLT. Do you see? We have KLT and we have KLT. So what can we do? We can basically equate this KLT together. But before we do that, what do we need to do? We need to make KLT in the first one subject of the formula, and here subject of the formula. So I'm going to start with this one because it's already here. So if I take the T to the other side, KLT, right, is going to be equals to 90 degrees minus T, right? Then taking this one, we're going to say KLT. If I take the S SLK to the other side is going to be equals to 90 degrees minus SLK, right? Since we have KLT here and KLT, we can equate them together. So let's do that. So it's going to be 90 degrees minus T, right, is equals to 90 degrees minus SLK, right? The 90s are going to cancel out, so you're going to be left with negative T is equals to negative SLK, right? Which is the same as angle T is equals to SLK. So we see the fact that SLK is just this angle, the one that we were required to prove, which is here, right, is equals to T. And what do we know? We know the fact that T is equals to P. Therefore, what can we say? Since T, right, from upwards is equals to T, therefore what? SLK is equals to angle P. Now moving to 8.2, it says in the diagram below, right, they tell us what? They tell us P, W, R, S are a cyclic quadrant in the circle centered O. So before we move on from the first statement, let's basically fill in the properties if we have a cyclic quad, right? What is the first one? We see the fact that since this is the center, right? Since this one is the center, let me just draw it. Let me just highlight it, right? I have angle at center twice the angle at circumference. Do you see that? So whatever this angle is going to be 2 times this one, that's what I see. Since this is the center and this is the circumference, that these two are equals to each other. OR, right, is equals to OW. Do you see that, right? So if these two are equals to each other, meaning the opposite angles are equal. So let me create a triangle there so that it doesn't confuse anyone. Let me use a different color. If this triangle, the yellow one, is an isosceles triangle because of the radius, this angle here is going to be equals to this one. Do you see that, right? Yeah. So I think that's the only thing that we can feel so far. Then they say triangle P, right, SW is an equilateral triangle. So we see the fact that this triangle, we have a big triangle. Let me just highlight it. Let me do it in green. So we see the fact that PSW, right, is an equilateral triangle, right? And let me just delete this one, the turquoise one. What are the properties of a what? Of an equilateral? Is that all sides are equal. So I'm going to do that. All sides are going to be equals to each other, right, in green. Let me do double lines so it doesn't confuse anyone. And all angles are going to be equal. If all angles are equal, since the sum of angles, right, the sum of angles is equals to 180 degrees, right? If the sum of all angles is equals to 180 degrees, if we divide the 180 by 3, we're going to get 60 degrees. So all angles here are going to be what? Equals to 60 degrees because it's going to be an equilateral triangle. So we're done filling in the properties of an equilateral. Then they tell us what? They tell us that TW, right, is a tangent to the circle at W. So we need to fill in the properties of a tangent and chord, right? Let's do that. So going here, we see the fact that at W5 is equals to 25 degrees. So since this is a W5, right, see it goes from here till it touches the chord WR, right, is equals to 25. That is equals to what? To angle S1, right? So meaning here it's going to be 25 degrees, and your reason for that is going to be 10 chord, right? So having read the information and filled in all the important necessarily things, let's answer the questions, right? So 8.2.1a, it says determine giving reason the size of S1, right? We see the fact that since we've filled in the diagram, everything is easy. So S1, angle S1 is equals to 25 degrees, and the reason for that is 10 chord theorem. Then B says determine the angle with the reasons the size of O, angle O1, right? Since this is 25, O1 is going to be 50 degrees because of angle at center twice the angle at circumference. So this is going to be 50 degrees, and the reason is going to be angle at center equals to 2 times angle at circumference, right? Then Then C says we need to find R1, right? So to find R1, we need to see where R1 is. Let me do it in green. R1 is here. Do you see? R1 is here. What do we know? We know the fact that, let me do it in black, R1 plus R2, right? Then plus P is equals to 180 degrees. And the reason for that is what? Is opposite angles over what? Opposite angles over cyclic quad, right? Are supplementary. So let me write that down. R1 plus R2, right? Plus angle P is equals to 180 degrees, right? Because opposite angles of a cyclic quad are supplementary. And the reason for that is opposite interior angles are supplementary. So meaning opposite angles of a cyclic quad are supplementary. So this will be your reason, right? So knowing the fact that this whole thing is going to be 180 minus thingy, we know the fact that now we need to find angle P, right? We know that it is 60 degrees, but you need to write it down. So angle P is equals to 60 degrees. And the reason for that is angles in an equilateral, angles of an equilateral triangle, right? So now we can substitute here P to find R1 and R2. So you're going to say angle R1 plus angle R2 is plus 60 degrees is equals to 180 degrees. Therefore, R1 plus R2, right, is equals to 180 degrees minus 60, making it R1 plus R2 is equals to 120 degrees. Okay? So having that in mind, now we need to find what? We need to find this one. This one I just highlighted in black, and we can find it by finding the sum of angles in a triangle. Since we have O1 as being 50 degrees and opposite angles of a isosceles triangle because of OR and OWR radius, we can find this, right? So let's do that. So now, right, we know the fact that OR is equals to OW, and the reason for that is what? Is radius. Therefore, what's gonna happen is that angle R2 is gonna be equals to angle W4 plus W3. Do you see this entire pink thing? Because as we're looking at the yellow triangle, right? And the reason for that is going to be what? Is going to be opposite sides equal, therefore opposite angles equal. Opposite angles equal. Okay? So what do we know? If these two are equal, then we can find the sum of sum of angles in a triangle. So we can find the sum of angles in a triangle looking at the yellow triangle just to find this, right? So if we say angle O1 plus angle R2 plus, you remember the fact that this one is a combination of two angles, angle W4 plus W3, right? It's going to be equals to 180 degrees. And that's what? Sum of angles in a triangle. Then state which triangle you're talking about. Triangle ORW, right? Then we already know the fact that R2 is equals to W4 and W3. So we're gonna substitute W4 and W3 by R2. So you're gonna say angle angle O1 plus angle R2 plus R2, right, is equals to 180 degrees. But we know what O1 is, right? So O1 is 50 degrees plus 2R2 is equals to 180 degrees. Take this 50 to the other side. We're gonna get that 2R2 is equals to what? Is equals to 130 degrees. Divide both sides by 2. Therefore, R2 is going to be equals to what? It's going to be equals to 65 degrees. That's perfect. But remember from this one, let me highlight. From this one, we know that R1 plus R2 is equals to what? 220 degrees, right? Let me do it in green here. I'm just going to write it here because I don't want to go up. So we know the fact that R1, right, plus R2 is equals to 120 degrees. So we already have R2 because it's 65. We just solved it. Therefore, R1 plus 65 degrees is equals to 120 degrees. Take the take 65 25 to the other side. Therefore, R1 is equals to what? Is equals to 55 degrees. I hope that made sense. So the last question says we need to prove as P, right, is parallel to what? To TW. So we need to prove that. We need to prove that this two lines is parallel. So what I'm going to use alternating. Alternating is a Z, right? So it's a Z or an M. So if we do that, if I just extend it, what I need to prove that W4 and W5 is equals to what? Is equals to S2. That's what I need to prove, right? So here, required to prove, right? Required to prove, if that's the case for me, I need to prove that angle S2 is equals to what? To W4 plus W5. And that's what I need to prove. So what I need to do is I need to find W4 because I already have S2 as being 60. I already have W5 as being 25. What I don't have is W4, right? So I need to find the sum of W4. I need to find the angle of W4. So to find the angle of W4, let me create a triangle. But if I draw a triangle, do you see the fact that the triangle that contains W4 is this one? The one in blue and dark blue. We have this angle, which is S1, and we have R. And here, the only remaining angle is W. It's only W4. So if we find the sum of angles of that, we can actually find we can find W4. So let's do that. What do we know? We know the fact that angle S1 plus angle R1 plus R2 plus W4 is equals to 180 degrees. And the reason for that is sum of angles in a triangle. Then the triangle that we're talking about, I forgot that part. The triangle that we're talking about is triangle what? SRW. So what do we have? We have S1 and we have R1 and R2. So let's substitute that. It's going to be 60 degrees plus this whole thing is what? It's 120 degrees plus W4 is equals to 180 degrees. So therefore W4 is going to be equals to what? 35 degrees. What did we require to prove the fact that S2 is equals to W4 plus W5, right? So now S2 is equals to 60 degrees. W4 plus W5 is equals to what? Is equals to W4 is 35 plus what? Plus W4. W4 is 35, right? And W5 is equals to 25, which is equals to 60 degrees. What do we see? We see the fact that therefore angle S2 is equals to W4 plus W5. And if they equal, and that is equals to 60 degrees, and if they equal, that means therefore SP is parallel to what? To TW. And your reason for that is alternating angles. 8.3 says in the diagram below, a circle centered at O is drawn. H, J, G, and L are points on the circle. Then they tell you that triangle HJL is drawn. Then they say HOG bisects JL, meaning it's perpendicular. It bisects it equally at M. Then they tell you the fact that HJ is equals to 12 root 5 units, and therefore JM is equals to 12 units, right? So 8.1. So 8.3.1 says if mg, which is this portion, is equals to 6 unit. So if the small portion is equals to 6 unit, and OM, right, which is from here to here, is equals to x, right? Write down HM from here to here. They want that in terms of x. So let's do that. So we know the fact that HM, right? So wait, before we move forward, this OG is equals to OH, and the reason for that is radius. Then what do we have? We want HM, right? So since OG is equals to what? See, it's is equals to OM plus MG. And therefore OG is going to be equals to what? To X plus what? Plus 6. So if this part is equals to X, this is equals to X plus 6, what we want, which is HM, is made out of what? It's made out of OH plus what? Plus OM, right? I said the fact that OH is equals to OG, and therefore OG is equals to X plus 6. So therefore HM is equals to what? To X plus 6 plus OM, right? Which is what? Which is X. Therefore HM is equals to what? To 2x plus 6. Then we done writing HM in terms of x. So then 8.3.2 says calculate giving reasons the length of the radius. I already say the fact that OG, right, is equals to OH, and there are radius, right? So what do we need to solve here? We need to solve this portion. Then from there, that's why we can find the radius. So the first part is we're going to use theorem of Pythagoras, because this is a right angle triangle. They gave us this side, they gave us this side. So the only side that's missing is this one, right? So the first one is going to be what? Stating the fact that OG is perpendicular to what? To JL, right? So we're going to say OG, right, is perpendicular to JL. And your reason is going to be what? Line from center to midpoint of chord. Midpoint of chord. That will be your reason. Then from there we can use what? Theorem of Pythagoras to actually find the remaining side. This is what? The hypotenuse. So it's going to be HJ squared is equals to what? Is equals to JM squared plus HM, right? Squared. And your reason for that, you're going to say Pythagoras. Then let's substitute inside. What do we know? We know the fact that HJ, right, is equals to 12 root 5 squared, and JM is equals to 12 squared plus HM squared, right? So this is going to change. The first one is going to change to 720 is equals to 12 squared is 144 plus HM squared, right? Take the 144 to the other side. It's going to be 720 degrees minus 144 degrees is equals to HM squared, right? So this side is going to give us what? It's going to give you 576 is equals to HM squared. Square both sides. HM is going to be equals to what? It's going to be equals to 24. But remember, we're not done, right? We know that HM is equals to 2x plus 6. So we need to solve for 6. We need to solve for x so that we can find the small portion, which is OM. So let's do that. So substituting 2x squared is going to be 2x plus 6 is equals to 24 degrees. 24 is equals to 24. Take the 6 to the other side. It's going to be 2x is equals to what? Is equals to 18. Therefore, x is going to be equals to 9. But we're still not done because we're looking for the radius. But remember that radius is equals to what? Remember going up that OG is equals to OH, and therefore OG is equals to OH, right? So we're going to take OG because of we can take any radius, and I said my reason is radius. So therefore OG, right, is equals to what? Is equals to OM plus MG. What is OM? OM is 9. Is the 9 that we found, which is x. So this is going to be 9 plus the 6 that they gave us. Therefore, that's going to be equals to, therefore it's going to be equals to 15 units. So OG is equals to 15 units. And remember that OG and OH were radius. So we have answered this question. So now let's do question 9. It says in the diagram below, it tells us that P, Q, R, S are points in the circle, right? So what do we know if there's points in the circle? We know the fact that angles in the same segment might exist. So let's check whether they exist. We see the fact that Q1 is equals to what? 2R1. And we also see the fact that this angle here, which is not labeled P what, is equals to S2. So that's angles in the same segment. We know that. So let's move on to the question. It says PS, PQ, and PR are produced to V, T, and W respectively. So it's saying the fact that they have extended PS, PQ, and PR to create V, W, and T. And they tell us the fact that VT is parallel to what? To SQ, which is this line. So what do we know about parallel lines? We need to check one of the properties. If I create an F here like this, what can we see? We see the fact that this angle is going to be equals to this angle, and that's what? That's corresponding angles, meaning also this angle is going to be green. And also if I go to the other side and connect it again, we see the fact that we have another F, meaning what? Meaning this angle is equals to what? To this angle. So that's what we know. Then they tell us the fact that SR, which is this one, is parallel to VW, which is this one. If those angles are parallel to each other, we can create an F going from F connecting to W, right? So meaning that angle W, is equals to angle R1, meaning this is going to be green too. And also if we connect it to the other side, we can create another F from P to V, and that means the fact that what? That angle V is equals to what? To from here to this angle, which is S1 and S2, and that's corresponding angles. So knowing that information, let's start to answer the questions. So now it says proving, giving reasons that TQ, let's mark it. I'm gonna mark it in black. They tell us the fact that TQ, which is this one, divided by QP, which is this one, is equals to what? To VW, and WR, which is this one, divided by RP, which is this one. We need to prove that these two are equal. But what can we see? What do we see? We see the fact that PV shares the same side for the triangle, the green triangle and the blue triangle. So we can use the side PV to actually get to this proof. So I'll show you right now. So let's start with the first one, which is TV and TQ. So we know the fact that TQ divided by QP is equals to what? Looking at the blue triangle, is equals to VS, because of VS is corresponding to TQ, then divided by what? By SP, because it's corresponding to what? To PQ. And your reason is going to be what? Proportion theorem. And you need to state which parallel lines are actually parallel to each other, but we need to state the parallel lines. So we know that from the blue circle is what? Is QS, right? Is parallel to TV. And now we're moving to the green one, the green triangle. We know the fact that from WR divided by RP, right, is going to be equals to VS divided by SP. And the same reason is going to be what? Proportion theorem. Then stating the parallel lines is going to be what? Is going to be SR is parallel to what? Is parallel to R, is parallel to WV. So what do we see? We see the fact that here we have a common equals to sign, meaning we can equate this two, right? So therefore TQ divided by QP is equals to WR divided by RP, and we're done proving the first question. Then 9.2 says T, which is here, and P, which is here, and V, which is here, and W, which is here. They say we need to prove this whole thing. I'm gonna do it in black so that you guys can see. They say we need to prove the one in black, and that it's a cyclic quadrilateral. So to prove a cyclic quadrilateral, we have three properties. I'll put them on the side, but here what I'm going to use is I'm going to use the one that says angles in the same segment, right? So we see the fact that from the diagram, without proving it, we see the fact that angle T is equals to angle W, so we're gonna basically state how they equal. So let's start. So the first part, we know the fact that angle Q1 is equals to angle R1. And your reason for that is going to be what? It's going to be angles in the same segment. And you see the fact that that's the first thing that we have actually proved here, right? Then from there, we know the fact that angle Q1 is equals to angle T, right? And your reason is what? Corresponding angles. Corresponding angles. And your parallel lines is what? Is that QS is parallel to TV, right? And we also know the fact that angle R1 is equals to angle W. And your reason is going to be what? Corresponding angles, but with different parallel lines, which is RS is parallel to WV, right? So therefore, angle T is equals to what? To angle W, right? Because of if Q1 and R1 are both equals to T and W, basically this thing, T and W can be equals to each other, right? Therefore, T, P, V, W is a cyclic quad, But then you need to have your reason. Your reason is converse, right? Comma, angles in the same segment. Angles in the same segment. And that's true because of T. If this was a cyclic quad, if there was a circle, T and W is angles in the same segment. So you're done with question 9. So now let's do question 10. It says in the diagram below, B, C, D are points on the circle. So we know the fact that what? B, C, D are points in the diagram, right? So let's look at this. We see the fact that they tell us that are points in the circle such that BC is equals to what? To CD. So we see the fact that BC is equals to CD. If they are equal, that means the fact that angle opposite are equal, meaning D2 is also equals to X. And I'm going to do this one in green, so that we can see, we can track it down which angles are all. So we can track all angles that are equals to X. And they tell us that ED is a tangent to the circle at C. So we see the fact that ED is a tangent to the circle at C and D, right? C and D. Right, so the fact that we see the fact that there is two tangent, let me highlight them. This is the first tangent in blue, and this is the second one. Since CE and DE are both tangent and they meet at E, if you can see that, right, that means what? That means the fact that CE is equals to what? To DE. So those two are equal. What does it mean if two sides are equal? Is an isosceles triangle, meaning what? Meaning the fact that angle B, angle C2 is equals to angle D1. That's what we know. And they tell us the fact that BC produced meets tangent DE produced at F, so it extends, DC extends to produce F, and they tell us the fact that angle B is equals to X. So they have that in the diagram. Let's use the 10 chord theorem. If this is tangent, if DE, right, is a tangent, that means what? That means the fact that this angle, right, D1 is going to be equals to X. It's equals to B, right? So this angle is going to be green because of this, and that's going to be what? 10 chord theorem. If this is green, that means the fact that this one is also green. Then 10.1 says proof giving reasons. Then 10.1.1 says E1 is equals to 180 minus 2x. What do we know? We know the fact that if it's 180, what do we know? We know the fact that sum of angles in a triangle is equals to what? To 180 is equals to 180, right? And 2x, we already have 2x, so it's easy to solve this. But first, we need to what? Connect it to x. What do we know? The first thing that we know is the fact that angle D1 is equals to angle, and that is going to be equals to x, and your reason is what? 10 chord theorem. Then we also know the fact that angle D1 is equals to what? To angle C2, which is equals to x, and your reason is what? Opposite sides equal, meaning opposite angles equal. So now what do we know? We know the fact that angle C2 plus angle D1 plus angle E1, which is what we want, is equals to 180 degrees. And your reason is going to be what? Sum of angles in a triangle. Sum of angles in a triangle. So now we can substitute C2 and D1 as being x. So you're going to have x plus E1 is equals to 180 degrees. This is going to give you 2x plus E1 is equals to 180 degrees. Take 2x to the other side, therefore E1 is going to be equals to 180 degrees minus 2x. Then you're done proving this. Then now 10.1.2, it says we need to prove similarities. So they want us to prove triangle. So this is required to prove. So we are required to prove that triangle ECD, let me highlight it here in a different color. I'm going to do it in yellow. ECD is similar to triangle CBD. The triangle, I'm going to do it in purple. So it's going to be CBD. So this other triangle. That's the true triangle that we need to prove similarities. So the first one is what? We see the fact that they all have x's and this one is going to be the same. So let's start to prove the fact that this one is 180 minus, this one is 180 minus 2x. And also let's prove the fact that this one is equal to x. Let's prove that D2 is equals to x. So let's start with D2. So D2 is equals to what? To x. And your reason is what? Opposite angles, opposite sides equal. Therefore, opposite angles equal. So we have proven that this is equals to x. So let's prove that fact that C3 is also 180 minus 2x. So what we're going to say? We're going to say angle B plus angle B plus angle D2 plus C3 is equals to 180 degrees. And your reason is going to be what? Sum of angles in a triangle, right? So what do we know? We know the fact that C3 is going to be equals to what? To 180 degrees minus 2x, because of B and D2 are x. So it's going to be minus 2x. So we have proven the fact that C3 is going to be 180 minus 2x. Now let's connect everything. What do we know? We know the fact that angle D1, right, it's going to be equals to angle B, and you can say proven because we already talked about it in the first question. This is proven, right? Then what can we say? We can say the fact that angle C2, right, angle C2 is equals to angle D2, which is equals to x, and your reason is going to be what? 10 chord theorem, right? So therefore we know the fact that angle E1 is equals to angle C3, and that's going to be equals to 180 degrees minus 2x, and you're going to say that it's proven because you have proven it above, right? So therefore, since we have three statements, which is 1, 2, 3, we can conclude that triangle ECD is similar to triangle CBD. And since all the things that we proven is angle, your reason is going to be what? A, which stands for angle. Because if this is angle, right? Then we're done with question 10.1.2. So now moving to 10.2.1. It says proof giving reasons that CD is equals to CE multiplied by BD. So we need to state where they are. Where CD is this one, the common side, right? Then they tell us the fact that is equals to CE, which is this one, right? Then multiplied by BD, which is this one. So we need to use what? We need to use proportion theorem, but now we're going to use the fact that since we prove similarity, this can be in proportion too. So let's use that. But before we do that, we need to basically take them out and put them in two triangles so that it's easy to basically find this one. So let's do that first. So now what we do is I took the two triangle and I wrote it outside, lining up the matching angles. We know the fact that E1, remember, is equals to angle. E1 is equals to angle C3. So that is why E1 is on top and C3 is on top. And we know the fact that angle D and C are x's and B and D are x's too, right? So what we need to do is after drawing your triangles, we have to match up the side that they talked about. We see from the first triangle, we have what? CD, which is here. And then we have BD, which is here. Then the other triangle, what we have, because it's CD squared, we also have CD, which is here, right? And we have what? We have CE, which is this one. So from that, what do we know? We know the fact that this one divided by this one needs to be equals to the matching side, which is this one divided by this one. So let's do that. So we know the fact that matching the sides, that CD divided by what? By BD is going to be equals to what? Match it with the side. This one is matched with this one. So they both need to be on the numerator. So you're going to say what? You're going to say EC divided by what? By this one matching with this one, which is going to be what? BD is equals to what? Is the same as DCD. You see that? Then we can cross multiply. When you cross multiply, you're going to have CD squared, because of it's the same thing, is equals to what? Is equals to CE, which is the same as EC multiplied by BD. So then you have found your question 10.2.1. So this is how you find it. Your reason here is going to be what? It's going to be that triangle ECD is similar to triangle CBD. Then you're done with this question. Then now we're going to do 10.2.2. It says CF squared divided by EF, right, is equals to BD divided by DE, right? So let's go mark what they're talking about. So I'm going to mark it in orange. So CF squared, CF, so CF squared, so they're talking about this one, right? Divided by what? By EF squared, which is going to be this one. It's going to be equals to BD, BD, which is going to be this one, and divided by DE, which is going to be this one. So CF squared, what do we need to do is first we need to prove parallel lines so that we can use the proportion theorem to basically solve this question properly, right? So let's do that. So the first part is that we need to prove parallel lines. So which lines are we proving that they are parallel? So we need to prove that BD, we need to prove that BD, right, is parallel to CE. After proving this, it's easy for us to use the top part of the triangle, the one that's produced. So let's start there. So what do we know? We know the fact that angle C2 is equals to angle D2. So we know the fact that angle C2, which is here, is equals to angle D2, which is here. You have already proved that. What did we say that is what? We said that's 10 chord theorem, but we already proved that this is equals to X. We're going to say what? We're going to say proven. If this two, C2 and D2 are parallel, are equals to each other, if we draw a line in purple and orange, if we draw a line across here, this is what? This is alternative angles. So therefore what? We have already proved the fact that therefore, if these two are equal and this is alternative angle, we know the fact that BD is parallel to what? To CE. And your reason is alternative angles, because they are alternative to each other. Okay, so now since now we know the fact that those are alternative angle, we can use the proportion theorem. So what I did is I took the big triangle and I wrote it outside so we can link everything. We know the fact that CE is parallel to BD, right? So the blue one is what we required to prove. So what are we required to prove? We required to prove CF squared divided by EF squared. So we required to prove that CF squared, right, divided by E by EF squared, which is this one in green, so then it's equals to BD, which is BD is here, right? So BD is here, divided by DC, which is here, so that's the things that we have here. So using the proportion theorem, what can we link? We can link these two sides together. So let's do that. So we know the fact that what? We know the fact that CF, right, divided by what? Divided by EF is going to be equals to what? This one needs to link with this one, which is going to be CB, right, divided by this one, which is in our case is going to be what? It's going to be DE. If we square both sides, it's going to give us what? CF squared divided by EF squared is equals to CB squared divided by DC squared. What do we have so far? We have the fact that we have DC here. So we have the denominator and we have the left hand side completely here. So we need to manipulate this one. So to manipulate that one, we know the fact that CB squared is equals to what? Is equals to CE multiplied by BD. We have proved it in 10.2.1. We know that. So we can substitute CB by what I just wrote, because we have proved it in 10.2.1. So let's substitute that. So it's going to be, so it's going to be CF squared divided by EF squared is going to be equals to what? To CE multiplied by what? By BD divided by what? By DE squared. But another thing is that now we see the fact that on the numerator on the right hand side we have BD, right? But here it's still the same thing. We have DE squared, and we need one of them. So in the numerator on the right hand side, this one needs to cancel with this one. But again, what do we know? We know the fact that CE is equals to DE. Let's go find CE. CE, this one I'm gonna put a cross by it, is equals to what? To DE, which is equals to this one. Remember, angles tangent touch at one point. That's why it's going to be equal. So since these two are equal, we can substitute what? CE by BD. So let's do that. So now it's going to be CF squared divided by EF squared, which is going to be equals to what? It's going to be equals to DE multiplied by BD divided by DE squared. Since we have DE on the numerator, I can cancel one of the DE in the denominator. So this is going to cancel and this is going to cancel. So we're going to have what? CF squared divided by EF squared is going to be equals to what? To BD divided by DE. Then you have proven the last question.